Hello and welcome to Lynchburg Live. I'm your host, Linda Smith. There's been a lot of cosmic activity recently in the form of visible comets, asteroids passing very close to us, and the meteor that actually impacted Russia in February, injuring numbers of people and causing unheard of amounts of damage. My guest tonight is Dr. Michael Solontoi. He's Assistant Professor of Physics and Astronomy and Director of the Belk Astronomical Observatory at Lynchburg College, and he's going to be discussing these things with me. Welcome, Mike.
Thanks for having me.
Glad to have you. How long have you been in your position as Assistant Professor of Astronomy at Lynchburg College?
I'm actually new faculty this year, so this is my first year at the college. This is my first year in Lynchburg. I'm enjoying myself thus far.
I was going to ask you how you like Lynchburg.
Yeah, I like it quite a bit.
It's a good family town.
Absolutely, absolutely.
All right, now you have quite a list of credits. Can you just tell us a little background on yourself?
Sure. I did my graduate work in astronomy at the University of Washington in Seattle, and then I did a postdoctoral research fellowship at the Adler Planetarium in Chicago, Illinois. Mainly I've worked on minor planet research. I've done things like look at asteroids, I've looked at comets, I've done direct observations where I've applied for and gotten telescope time to go and directly observe and then analyze these objects. And then I've also data mined surveys where there's been already a telescope out there that's just kind of scanned the sky night after night after night, and it's up to me to find all these objects in it.
What led you to a career in astronomy? Was this something that happened as a childhood dream?
It really kind of was. Like a lot of kids, I think, I was drawn by the two siren songs of science. Little kids get drawn into science by dinosaurs in space. Dinosaurs in space, dinosaurs in space. So I'm studying the bit of space that killed the dinosaurs. Cool. So I think I was able to keep that childhood dream alive. So.
And incorporate both
and
of those
incorporate
things.
it. It's great. I always, in fact, whenever I get to teach the solar system course, I always have the Death to Dinosaur Day, where I get to talk about, throwing giant rocks from space at the Earth and wiping out the dinosaurs.
That's just so cool.
It really is. It really is. I like it a lot.
All right, tell me, what's involved with your job at Lynchburg College?
We are a teaching college, number one. So my main job there really is undergraduate education. I teach courses in the physics department. I teach the astronomy courses there. I run the Belk Observatory, both for our own students and then for public outreach. We have at least one public activity a month out there. I also do a bit of research. I've maintained some of my research collaborations with other astronomers I worked with at the University of Washington while I was there, and then I'm still in contact with several of my colleagues at the Adler Planetarium. So do a little bit of everything, but definitely teaching first. So,
when I was researching this show and learning about you, I was not aware of the Belk Observatory being here in this area. Could you tell us about that?
Absolutely. It's really a fantastic facility. It's out in the very dark sky region out north of Bedford town itself, out towards the hills there. It's on out at the Claytor Nature Center, which is a large nature preserve that is managed and run by Lynchburg College. And we have a 20-inch telescope, a number of 8-inch telescopes, a number of binoculars, a 13-inch telescope. We have a lot of facilities for people to look at. And quite honestly, the setup there really compares favorably to a lot of professional observatories I've been to. I've actually been to a number of professional research observatories at various locations, not to be named right now, that don't have the control room. It's modern. There is a control room. It's heated. The bathrooms are heated.
That's wonderful.
There are bathrooms. It's a for an astronomer, for a place that you might have to spend all night at. You got a coffee machine, a popcorn maker, computers, and a bathroom. You're set. That's you really, as an astronomer, you really can't ask for a whole lot more.
Now, do tour groups go there, or can like clubs?
We do occasionally open up. Our main source of outreach, though, is through our monthly open houses. And if you just go to the Belk Observatory webpage off of the Lynchburg College site, it gives you all the information on how you go about getting a ticket for that. They're free, and we're happy to see people. We keep the numbers fairly small because we want everybody to have a really good time there and have some specific one-on-one interactions with our volunteers, our docents, and the telescopes in the sky. It's really a really neat experience. It's not one of these things where you go out to an observatory, you wait in line for 10 minutes for a 15-second look through a telescope. It's you and a couple other guests and a few docents and a bunch of telescopes and a great big sky, and it's a really fantastic.
I think it's just wonderful to know that there's something like that in the area.
Absolutely.
All right, now we have had recently, since the first of the year, some pretty impressive cosmic activity. And I asked you this on the phone when I was talking to you. Do you think that we're more aware of it because of the rapid communication systems we have, or has this always been going on?
It's always been going on, and I think we are getting more aware of just stuff happening around because of the connected nature, the wired nature of the world. Almost everybody who has not only does everybody have a cell phone, but every cell phone has a camera and a video. You can't do anything anymore without a video of it appearing somewhere or a picture appearing of it somewhere. People are occupying more of the world than we ever have before. We're more connected than we ever have been before. So we're not in a special time. These events aren't happening more frequently. We're just a little bit more aware of them. We also have better technology. We can physically see and identify and track much, much smaller things than we could have 10 years ago or 20 years ago. I mean, the very first asteroid wasn't discovered until 1801. So prior to 1801, no one
knew anything that was going on.
Yeah. We had no one knew of any asteroids coming by us, even though they've been hitting us for years and years and years. I mean, you take a look at the moon; it's covered in craters.
Right.
The moon's been around as long as we have. It's a continual process.
I just think it's so interesting. Now the 2012 DA14 asteroid that came so close to us.
Yes.
I don't think 17,000 miles is close, but apparently it's close for something like this.
For astronomy, it's awfully close. That's closer than all of the geosynchronous satellites, the satellites that help our telecommunications. So it actually passed within a ring of all of our telecommunications satellites. That's really close. That's only 2 diameters of the Earth. So if the Earth was here, there, that's where the asteroid was. That's really close. That's about 1/10 of the distance to the moon. And when you have something that close to the Earth traveling at about 5 miles a second, it doesn't take that much to, that's a pretty close shave. That's awfully close.
Right. What if the path of this thing got interrupted by other space debris? Could it possibly have thrown it into a direction that would
other
impact
impacts?
us?
Yeah, and actually there's a lot of different things that we can't really know of specifically that can alter the asteroid's path just enough to make it a clean miss or a clean hit. One of those could be an impact, but just like something significant hitting the Earth, the odds of something else hitting that asteroid enough to nudge it is pretty small. Right. It's on a given orbit, insignificant. Now, if you let it go for, if you look at it over the course of millions and millions of years, things are going to hit it, just like things hit the Earth. But the odds of anything bumping it at the last second are pretty negligible.
Now, is it true that every year one of these DA14 or a similar DA14 asteroid passes close to us?
Absolutely. Maybe not quite this close. This was the closest approach of an object this size. And actually DA14, this asteroid here, is a little bit smaller than we thought it was. We originally thought it was something around 50 meters, maybe a little bit bigger. When it tumbled by us, we were able to bounce radar off it, much like they do for seeing the storm clouds rolling in. We were able to get some pictures of it from its radar image. It looks like it's a little bit smaller, maybe only about 20 kilometers, 20 kilometers would have been significant, 20 meters by 40 meters, so about 30 meters across. So it's a bit smaller than we thought it was, but still, that's a pretty big rock. And in the time that we've been studying asteroids and watching it, this is the closest approach of kind of one of these 50-meter class objects that we have actually recorded. So does this happen every year? No, this was a little bit special, but something the size of 2012 DA14 does come by us very frequently. If you look at the paths of near-Earth asteroids. Just a couple days ago, an asteroid passed within a couple dozen distances to the moon.
Was that Pan-STARRS? No, that's something else.
That's a comet. That's
okay.
much further away.
Okay.
And you know, in 2 days from now, there's going to be about a 3 or 4 kilometer asteroid that's going to pass maybe about 50 times the distance to the moon. So things in our neighborhood, but not kind of nail-bitingly close or anything like that.
How is the path of something like this predicted? Or is it just because it repeats itself, sort of? It
needs to be predicted because these small objects in particular can actually have their orbits modified on very short periods of time. It's a craft. It's highly skilled people, and particularly there's a number of people, for example, in the near-Earth object offices of the Jet Propulsion Laboratory who work with NASA and so forth. They do a lot of really detailed analysis. It's all physics. Fundamentally, you have a rock, and you have the sun, and you have all the other planets and all the other asteroids, and they're just pulling on each other with gravity. And gravity is something that Isaac Newton wrote down very explicitly how it works. And these objects are far enough apart and low enough mass that we don't have to really worry about all the fancy stuff that Einstein came up with. The general relativistic corrections to this is very small. So this is the same physics that you would learn in an introductory physics course. It's the same physics you would learn then in a junior level mechanics course. It gets difficult because you could explicitly, anybody in any physics major around the world could write down for you if there was nothing in the world but the sun and an asteroid. They could tell you exactly where that asteroid is going to be between now to the end of time.
And that's great.
But here's the kicker. Add one other object, like Jupiter, and there's not a single person in the world who could tell you the answer. The problem becomes intractable, so we have to simulate it in computers. We feed this in, and what we do, we move everything forward a day, and we see where all the positions are. And then we recalculate all the gravities, and then move it forward another day. See where everything is, recalculate all the gravities. Move it forward, because all the other planets and asteroids perturb and pull on these. These asteroids are small enough that actually just the pressure from the light of the sun can push them around, change their orbits. We're moving through the galaxy. We're slightly above the galactic plane. There's a tidal force from our galaxy that slightly perturbs things. And if you want to know whether or not an asteroid is going to hit us or not, you have to know its position to within about 7 minutes.
That was my next question.
Yeah, you have to know it within 7 minutes, because in 7 minutes, here's the Earth right here. 7 minutes later, it's right here. That's how long it takes the Earth to move its complete size in our orbit.
Right. If something like that had impacted us, what would have been the results? So
2012 DA14 is not any type of civilization killer. It's not. It's going to wipe out people. So it's not a good thing. But it's what's considered a regionally devastating. If it lands in your town, you've had a very bad day. If it lands on the other side of the world, your heart goes out for this tragedy that just occurred. But it's not big enough to, well, for one thing, it probably wouldn't actually make it to the ground. More than likely, 2012 DA14 was still small enough that it would have done something very similar to what the Russian meteor did. It would have airbursted. The difference is that it would have been much, much larger. And its airburst would have actually, instead of just rattling houses, breaking windows, knocking down structures, it would have flattened. It would have, like, setting off a Cold War era nuclear weapon as an airburst. It would have wiped out a city-sized area. It would be very comparable to the Tunguska blast in 1908, which flattened thousands of square miles of forest out in Siberia.
Right, the Russian meteor.
Yes.
And the DA14 had nothing to do with each other, even though, was it the same day that it happened? Or
same
within
day.
That's what I thought it was the same day.
Completely unrelated objects. There's actually uncountable numbers of things going around us. In fact, if you look up at night, you'll see shooting stars. Those are little tiny bits of dust and grains just burning up in our atmosphere. The two objects had completely different orbits. They're basically mutually perpendicular to each other. There was almost no way that they could have ever have been related in any way, shape, or form. It's just sometimes when you roll the dice, you get a lot of sixes all at once.
Were people aware that this meteor was going to do this over the Urals region in Russia?
Not at all. Not at all. The first idea that it was happening was some of these dash cam videos where you can see this burning streak of light going through the sky. It's the first warning we had. We can barely, 2012 DA14 was only discovered because it made a relatively close passage to Earth in 2012. It came within about 1 million miles of our planet, which for an object that size, it still was pretty faint, but we were able to detect it. The Russian meteor was even smaller, and we hadn't seen it before. Its orbit doesn't bring it by the Earth all that often. It had a much larger orbit that it's projected that it went all the way out into the asteroid belt before coming in. And things that size, we just really have no real accounting of where they are. They're too small for us to reliably identify at this point in time.
You know, just using this Russian thing as an example, how prepared are we for something that might crash into us? And what can we do about it anyway?
Well, optimistically, I would like to think that the world has its act together enough that given 20-year warning, we could do something about it. We don't exactly know what that something is yet. There's a number of other ideas of how to deflect an asteroid, ranging from you set off explosives near it, so it just kind of pushes away. One thing that we know, we don't want to blow it up, because then instead of one big rock coming at you, you've got lots and lots of other rocks, and instead of one big crater, you get thousands of little air bursts, and that's not really a good alternative either. The idea is that you want to nudge it some way, because all you have to do, again, 7 minutes. You just have to change its orbit so it gets here 7 minutes beforehand or 7 minutes later, and you're golden. You don't have to worry about it. And there's all sorts of things you can do. You could even, as goofy as it sounds, if you just painted the asteroid, just dump a bucket of, well, a really big bucket of paint over the whole thing, that would change its thermal properties, it would change how it interacts with the sun, and it would actually change its orbit ever so slightly. This doesn't sound pessimistic. Something big is suddenly discovered that's on its way with just a very short period of time. I'm not too optimistic about where we are in terms of preparation. On the other hand, these events have gotten people talking about it, which is good, because if we want to, as a civilization, as human beings, survive for on and on and on, and not hand in our civilization card to the cockroaches someday, we're going to have to deal with this. We're going to have to deal with this. It took out the dinosaurs, and the dinosaurs, as any kid, are huge and scary, and you know, so we're going to have to deal with it someday, and we might as well, since we now have the technology to start detecting them, might as well start thinking about how to mitigate them.
Right, you brought some great pictures, but before we show those, please tell our audience what this is behind us.
This is a shot of Meteor Crater, Arizona. It's about a kilometer-wide hole in the ground that was blasted out of northern Arizona about 50,000 years ago. Much more significant impact than either this Russian meteor or what 2012 DA14 would have done. This was either a fairly large or a fairly dense impactor that clearly made it all the way down to our planet and excavated a kilometer-sized hole in the ground. It is very similar to many of the small craters we see on the moon. It's this big, beautiful, bowl-shaped object. It's really the best preserved large impact crater on the planet. And this is actually where the Apollo astronauts went to train to explore the moon. They went and trundled around in this crater because it was one of the only craters they could go to here on Earth.
Right, Phil, if you'll go on and show the rest of the pictures, we'll get Mike to tell us what they are.
This is a image made by the Near-Earth Object group at NASA JPL. It's an orbit diagram showing the passage of 2012 DA14. The large circle you see there is the orbit of the moon. The small green circle is where all our communication satellites are, and you can see that 2012 DA14 actually passes in between that. It curves a little bit. The orbit of this asteroid has now been changed to one that's almost interior to the orbit of the Earth now. That is a beautiful image of an asteroid. And what's neat about this one is that it shows that even small asteroids, this isn't a really large asteroid, can have moons also. The small little object over there is actually a little moon. This is the asteroid Ida with its little teeny tiny moonlit dactyl. What's
the composition of an asteroid?
They're rock. Well, I mean, it actually very different types of rock. And when I say rock, I mean it in a very broad sense. We have asteroids range from very, very primitive asteroids, asteroids that are very, very small, never had a chance to really do any sort of geology. They still really represent the primitive building blocks of the solar system, and they're very rich in carbon and materials and very unprocessed things. And then it can go all the way to very large asteroids. The large asteroid Vesta, for example, the surface of Vesta appears to be made out of basalt, which is lava rock. It's the same type of rock that you would find in Hawaii or the Pacific Northwest or the Indian subcontinent or any of the volcanically active regions on our planet. So they can range from very primitive things that the rock structures are unheard of on this planet, all the way to things that are very kind of planetary in characteristics. So they're basically made out of the same stuff the planets are: rock, iron. That is at least believed to be an image of part of the Russian meteor. So this is now a Russian meteorite. Difference is, if you look up, it's a meteor. If you look down, it's a meteorite. So that is a very small piece of this asteroid. It is a very rocky asteroid, and it's still currently being studied. They actually have enough pieces of it that's going off to different research institutions. We're going to find out about this extraterrestrial object. That was the Russian meteor in air. That's the contrail left by this thing. It tore through the atmosphere. It set off several shockwave explosions, and that's really what did the damage. The meteorites fell onto the ground, and holes in the snow, holes in the ice. But the damage was really done by this shockwave. It was just massive, essentially a massive sonic boom was set off as this thing broke through the atmosphere, as it fragmented, as it tore apart. And it was that shock wave that went and then blew out windows, and almost all of the injuries were a result of things like broken glass and collapsing buildings and things. This is something interesting for local. Our state has a nice impact crater in it. You can't see it. It has no surface expression. But 33 million years ago, there was a impact right about where Chesapeake Bay is today. And the crater extends right over the grounds of NASA's Langley facility. The Chesapeake Bay Bridge and Tunnel goes right through this structure. Again, it's not anything you'd see from space, but if you dig down, like say you were building a bridge and tunnel, you're going to find a whole bunch of what we call impact breccia, which is this rock that's formed when a large meteor strikes the Earth and explodes. It's this rock that all gets kind of fused together. It has almost like a concrete-like mixture. That is the Belk Observatory. That's the observatory we have up at the Claytor Nature Center. The large dome houses our 20-inch telescope, and then the other building there is our control room with our nice heated facilities. And just, it's so nice. This is the asteroid Itokawa. It's a small asteroid, maybe about a ½ kilometer across. I mean, it's much larger than the ones coming near us. What's fascinating about this is that we have pieces of this asteroid on the Earth. The Japanese spacecraft Hayabusa landed on this asteroid, scooped up some of the dirt, and brought it back to Earth. So we actually have samples. This is one of only 4 objects in the solar system that we have gone to, collected pieces of, and brought them back. The moon, we've collected particles of solar dust, we've collected parts of this asteroid, we've collected parts of the comet Wilt 2.
That looks like a moldy potato to
Yeah,
me.
and that's the other thing. Notice what you see. There's no craters on that. This asteroid is probably a rubble pile. It's probably just a big sack of gravel held together by gravity. And when something hits it, it just quivers around like a big ball of rock jello and quickly smooths out any sort of craters. Cool. It's all covered in boulders and pebbles and this really, really fine powdery stuff called regolith, which is basically rock dust. That is the KT boundary. That little brown smudge running across the middle of that line is the rock and dirt that was laid down during the KT impact. It separates the very white, fossil-rich rocks from the lower Cretaceous region from these dark, dead rocks right above it. This little smudgy brown line, the rocks in it are just completely chock full of elements that we don't find in abundance on Earth, but we find in incredible abundance in asteroids. And it was this, looking at this little layer, that led Louis and Walter Alvarez to propose a giant impact hit the Earth to wipe out the dinosaurs. This is a much larger asteroid. Again, now you can actually see a lot of craters and some structure on it. Just giving you an idea of, this is typically what we picture when we see an asteroid. What do most asteroids look like? Kind of a crater-covered potato. Take a potato, paint it gray, grayish brown, pit it full of craters, you've got an asteroid.
You know, I'm not hungry, but that reminds me of cheese, and the other one reminded me of a potato.
Yeah. This is the Mannequin Reservoir up in Quebec, and it's one of the few surface craters. It's a very large ring lake. You can see it from outer space. It's the remains of a very old, ancient impact that happened up in the Canadian Shield region of our continent. And here is a sample of different types of meteorites we find. Up in the really dark rock there is one of these very primitive objects. Then we have things that look like rocks that you might find around. And then from the cores of larger asteroids, we find iron meteorites, big hunks of pitted iron that have landed on the planet. Cool. This is a region of Siberia that was devastated by the Tunguska blast in 1908. So you can see just trees just knocked flat over by the impact, or the air burst. It didn't actually hit the ground. And this is the large asteroid Vesta, and we just had a spacecraft leave Vesta, where it had been orbiting for nearly a year. So we have a fantastic map of this asteroid. This asteroid's about 500 kilometers across. It was the 4th asteroid ever discovered.
That's a moldy grapefruit to me.
Moldy grapefruit, there you go.
All right, we only have about 3 more minutes,
No
believe
problem.
it. But I want to know if there's a website that people can go to if they have an interest in learning more about what you're talking about tonight.
For near-Earth objects, I can't recommend any site higher than JPL's website, which is neo.jpl.nasa.gov. They do a fantastic job. They do press releases. They have these little orbital diagrams. Otherwise, for just what's in the sky, take your pick of any of the professional websites. Spaceweather.com, space.com, Sky and Telescope magazine has skyandtelescope.com, Astronomy magazine has astronomy.com. They're all commercial ventures, so I'm not going to recommend one over the other unless they want to sponsor me or my research. But any of them, they're going to tell you beautifully, like, hey, there's a comet in the sky, there's this event, that event going on, and they'll tell you how to look at it. And just take your pick on whichever one has the least offensive ads for you to look at.
Mike, I thank you so much. We're running out of time. I hate to, because I have more questions I could ask you, and you've been wonderful. But thank you so much for coming and telling our audience about this. I think it's so interesting.
I've had a great time, anytime.
Thank you. I hope you've enjoyed tonight's show. My next show will feature CVCC's YAY program, Young Entrepreneurs. Thank you so much for watching. Have a wonderful evening. Good night.